Hello, ladies and gentlemen. Thank you for joining me once again. We're continuing our look at the 2017 Open paper. It is I, Root Beer, and we're on B2. So if that's what you're looking for, let's dive in together. And of course, if that's not what you're looking for, feel free to browse around and look for other questions from the 2017 Open. I am sure they are poking around my channel somewhere. Okay, so B2, what have we got here? There are 20 people in a room with A men and B women. Each pair of men shakes hands, each pair of women shakes hands, but there are no handshakes between a man and a woman. The total number of handshakes is 106. Determine the value of A times B. Okay, interesting. I know what they're after, I'm pretty sure, because handshaking is something that actually comes up a fair bit when you learn some combinatorics. I think what they want to say is each pair of men shakes hands exactly once. That sort of a thing. Anyways, okay, so what do these handshakes look like? And I mentioned combinatorics. Specifically, it happens a lot with graph theory. So imagine I had four men. I could represent them as dots, and I can represent a handshake between a pair of men as a line connecting those dots. There's only going to be one line per pair of dots. And we get a structure called a complete graph. If you're interested in these things, this is K4. These are called complete graphs. But I assure you, you don't need to know this or the terminology to figure out the answer to the question. I'm just putting this up there in case somebody wants to look up this sort of thing. If this is really your style of a problem and you like this sort of a thing, no sense in waiting until university to learn some graph theory. Okay, so complete graphs, if you want to learn about them, there they are. But I will not be using this terminology anymore. It's just purely there for interest. Okay, so how many lines are there when four men shake hands? So how many handshakes are there? 6 lines, so that's 6 handshakes. Okay, what if we had a fifth man? We add in a fifth man over here in pink. And he shakes hands 1, 2, 3, 4. Each time we add a new man, he's going to shake hands with the remaining men. So we get 6 plus 4, 10 handshakes. So 10 handshakes for 5 men, 6 for 4 men. If we added in another one, say this blue man from the blue man group, we add in 5 new lines because he shakes hands with the previous 5 men. So now it's 15. Handshakes, right? And you might notice a pattern. We're going up by 4 and then by 5. So for n, or well, not n, let's say a men, there will be, and incidentally, we could do this pattern a little easier. With 1 man, there's 0 handshakes. With 2 men, there's 1 handshakes. With 3 men, we add in 2 more. So the pattern for a men would be you do 1 plus 2 plus 3. Well, technically 0 plus 1 plus 2. But we just keep adding on. And when we added in our 5th man, we added on 4. When we added on our 6th man, we added on 5. So we will add up all the way to a minus 1. Right? And the same sort of thing for the women. Now, adding up these numbers, quite regular, 1 plus 2 plus 3, there is a pattern to these sorts of things. Okay, there's a nice formula for this sort of thing, and if you haven't seen it before, I'm not going to prove it, but if you haven't seen it before, I highly recommend you learn it, because it pops up a lot on contests. There's just some things that pop up all the time. Things like a 3, 4, 5 Pythagorean triangle, or really any of the small Pythagorean triples. That stuff happens all the time. Similarly, this formula seems to come up a lot on lots of contests. Multiple choice ones, written ones. You never have to reprove it on a written contest, but it is a very, very useful formula to know. So here's the formula. If I'm adding up the first n numbers, and you can have the 0 or not because, well, adding 0 doesn't do anything. But if I'm adding up the first n natural numbers, the formula is n times n plus 1. There's a neat proof to this, and I might have a video, or I might someday do a video about it, because it's nice and neat and interesting. But we're not here to prove things. This is now just a formula that you can have in your back pocket. Okay? If I haven't done a proof and you'd like to see one, feel free to leave a comment down below, and I might be able to get to that at some point in the future. Okay? So here's our formula. So if we're adding up, so for A men, there will be A minus 1 times A, because we're adding up to A minus 1. So A minus 1, A minus 1 plus 1 is just A over 2 handshakes. And for B women, there would be B minus 1, B over 2 handshakes. Right? So that's what we've been told. The men shake hands, the women shake hands, no handshakes between the men and the women. So there's no sort of overlap there. Whoops. Pressed the wrong button there. Alright, and what do we know? We know there's 106 handshakes in total. So that's going to be A squared minus A over 2 plus B squared minus B over 2. Okay, so let's change that to 212, and then we've got A squared plus B squared minus, I'll change it to an A plus B, like this. Okay. So, where can we go from here? So 212 needs to be a little something like this. Now, I honestly can't think of what to do. I was hoping we'd get a difference of squares, but we don't have a difference of squares, which is a bit of a shame. But we just need to solve, and it's one equation with two unknowns, so we likely can't solve for A and B individually. But we could definitely figure out their product, right? Right? So how might we figure out the product? So we know 212 looks like A squared plus B squared minus A plus B. Okay, well, this is looking somewhat similar to A plus B squared, but we've got this minus 2AB business kicking around. Well, I suppose we could change this to 212 is A squared plus B squared plus 2AB minus 2AB minus AB. Now, why am I doing that? Okay, so adding in something and then immediately subtract it, I don't actually change the sum. But now with this 2AB here, I can group this part as A plus B all squared. And then we've got minus A plus B, and then of course a minus 2AB, but we'd like to know what minus 2AB really is. Okay. Now where to go? Now where to go from here? I was trying to get to a quadratic. But I suspect that might not go well for me right now. This is what? This is B2, so I shouldn't be, well, hopefully I shouldn't be stumbling like this. I can't think of a thing to do right now. I mean, if worse comes to worse, I could just start picking values for A and B, because the handshake pattern, and the number of handshakes you're going to have is not too bad to work out. And so I could just list them out and try and find two that add up to 106, but I'm trying to be better than that. I'm trying to be a bit more clever than that. But I just can't seem to think. And we want A times B, not A plus B, A times B. Oh! I'm an idiot. There it is. There are 20 people in the room. Okay. I missed a very obvious thing. The lesson here, to turn my failure into a lesson, is always read the question. And I'm sure you did, and I didn't. This is a problem I have sometimes. A plus B is 20. So, okay, we probably still would have needed to do this arrangement here. Although, maybe you could have changed all these B's into 20 minus A's and gotten a single quadratic in terms of A, and then solved for two possibilities between A and B, then that would have been fine as well. But what have we got? 212 is 20 squared minus 20 minus 2AB. So that's 400 minus 20. So 212 is going to be 380 minus 2AB. We can rearrange 2AB is 380 minus 212. And what we want is A times B, so that's going to be 190 minus 106. 90 minus 6 is 84, so A times B is 84. And that's the final answer. Okay, good. It was driving me absolutely nuts. Completely bonkers. Because we didn't have enough information. So we did actually have 2 equations and 2 unknowns, and I'm willing to bet A is 7 and B is 12. Actually, this is just a guess based off the 84. It might not be this. It could be something like 4 and 21, but I think these numbers will do the trick. With 7, you'll get 6 times 7 over 2, 21 handshakes for the men. And with B is 12, you'll get 11 times 12, which is 66 handshakes for the women, and that is not enough. So what else could we have? We could try the 21 and the 4. So there'd be 3 times 4 over 2, so there'd be 6 handshakes for the women, and for the men it would be 20 times 21 over 2, so that'd be 210. That'd be 216. That's not going to work. What else could we have? I mean, we don't need to figure out A and B, and I could always use a quadratic to figure this out, but I'm just trying to mess around with it and have fun with it in my head. 6 and 14, so that'd be 5 times 6, so 15 for the women. 13 times 14 over 2. 13, so that'd be 91. There we go. So there's 14 men, 6 women, or 6 men, 14 women. You don't actually need to work that out. What we wanted was the A times B is 84. And don't be like me, folks. Always read the question. 20 people in the room. I'm glad I went back and checked that. Okay, up next will be question B3, and I will see you for that next time.